August 24, 1944. Chartres, France. Major General John C.H. Lee stood in front of a map that showed him exactly how badly the Allies were losing, not to the Germans, to mathematics. The red pins marking American divisions stretched across northern France in a line that grew longer every single day. Each pin represented roughly 15,000 men. Each man required 100 pounds of supplies per day: food, ammunition, fuel, medical supplies, spare parts, uniforms, everything. The math was simple. 28 divisions times 15,000 men times 100 pounds equals 21,000 tons of supplies per day, every single day. The problem was equally simple. Those supplies were 400 miles away, sitting on Normandy beaches. The French rail system had been bombed into rubble by the Allies themselves weeks before D-Day. The major Channel ports were still in German hands, and General George S. Patton's Third Army was racing across France at 80 miles per week, outrunning every supply line the logistics officers had ever planned for. Lee's staff had just delivered the devastating projection. At current consumption rates, with current delivery capacity, the American advance would grind to a complete halt in 72 hours. Not because of enemy resistance, because the tanks would run out of gas. Lee looked at his operations officer, Colonel Gordon Tate. "What do we have?" "Trucks, sir. About 7,000 of them scattered across 132 different transportation companies. No centralized command, no dedicated routes, no priority system. They're hauling whatever they can, whenever they can, however they can." Lee studied the map. The distance from Cherbourg to Chartres was roughly 250 miles. Round trip, 500 miles. A loaded truck averaged 30 miles per hour on French roads. That meant 17 hours of driving, plus loading time, plus unloading time, plus maintenance, plus driver rest. Call it 24 hours minimum for one round trip. One truck could make one delivery per day if everything went perfectly, which it never did. Lee did the math. 7,000 trucks times 2.5 tons average load equals 17,500 tons per day, theoretical maximum. They needed 21,000 tons, and that assumed 100% operational readiness, 0 breakdowns, perfect weather, no German interference, and drivers who never slept. It was impossible. Lee looked up from his calculations. "We have 36 hours to make it possible." Stakes: the tyranny of distance. The crisis facing Allied forces in August 1944 was the predictable result of spectacular success. Operation Cobra, the American breakout from Normandy, had shattered German defences faster than anyone had dared hope. Patton's Third Army, unleashed on August 1st, had torn through Brittany and was now racing toward Paris. General Courtney Hodges' First Army was advancing on a parallel axis to the north. British and Canadian forces were pushing east. The German army was in full retreat. It was the kind of pursuit that could win wars, if the pursuing army didn't starve to death first. The fundamental problem was that nobody had planned for this. Allied logistics doctrine assumed a methodical advance of perhaps 3 to 5 miles per day. Supply lines would be established, rail networks would be repaired, ports would be captured and restored to operation. Each phase would consolidate before the next phase began. But Patton wasn't interested in methodical. His Third Army was covering 20-30 miles per day, sometimes more. On August 7th alone, elements of his 4th Armoured Division advanced 58 miles. The logistics system couldn't keep up. It wasn't designed to keep up. Consider the fuel situation. A single M4 Sherman tank consumed 1.6 gallons of gasoline per mile. An armoured division had approximately 186 Sherman tanks, plus hundreds of other vehicles, half-tracks, trucks, jeeps, tank destroyers. Total divisional fuel consumption during operations, roughly 50,000 gallons per day. Patton had 6 divisions. That meant 300,000 gallons of fuel per day for Third Army alone. First Army consumed similar amounts. Total American fuel requirement, 800,000 gallons per day, and fuel was just one category of supply. Ammunition consumption varied wildly based on combat intensity. A division in heavy combat could expend 500 to 700 tons of artillery shells, mortar rounds, small arms ammunition in a single day. A day of light contact might use only 50–100 tons. But the logistics system had to plan for heavy combat every day because you couldn't predict when it would happen. Rations were more predictable but still substantial. Each soldier required approximately 6 pounds of food per day. A division of 15,000 men needed 45 tons of rations daily. Then there were spare parts, medical supplies, replacement weapons and equipment, clothing and boots, signal equipment, construction materials. The list was endless. All of it had to come from Normandy because the major French ports remained in German hands. Cherbourg was available but had been heavily damaged by the retreating Germans. Its capacity was limited. Le Havre, heavily defended. Brest, under siege. Calais, German fortress. Dunkirk, German fortress. The Allies had won the Battle of Normandy, but created a logistics nightmare in the process. The pre-invasion bombing campaign had deliberately destroyed the French railway system to prevent German reinforcements from reaching the beaches. Mission accomplished. But now those same destroyed rail lines meant Allied supplies couldn't move inland either, which left trucks. The US Army had anticipated this to some degree. They'd brought thousands of vehicles ashore, 2.5-ton GMC Jimmy trucks, 1.5-ton Dodges, specialized fuel tankers, repair vehicles. But these trucks were organized into independent companies assigned to various headquarters. There was no unified trucking system, no dedicated supply routes, no traffic control. Trucks competed with tactical units for road space. They got caught in traffic jams that stretched for miles. They broke down and blocked entire highways. They drove at different speeds, creating chaos. And crucially, they had no priority over other military traffic. A truck carrying 10,000 rations for a frontline division had the same priority as a staff car carrying one colonel to a meeting. The system was breaking down. On August 20th, elements of Patton's Third Army were ordered to halt operations. Not because of German resistance, because there was no fuel. Tank crews sat idle beside their Shermans, watching the enemy escape, unable to pursue. Artillery units rationed ammunition, firing only at confirmed targets. Infantry divisions stretched their rations, reducing meals. The German retreat was becoming a German escape, and the American advance was grinding to a halt for the most inglorious reason possible. They'd run out of gas. Something had to change. And it had to change immediately. The 36-hour miracle. Major General Lee's 36-hour planning session began at 1400 hours on August 24, 1944. Present were representatives from the Motor Transport Division, the Quartermaster Corps, the Transportation Corps, engineer units, and combat commands. The mission statement was brutally simple. Transport 100,000 tons of supplies from Normandy to forward depots near Chartres by September 1st, 8 days. That was 12,500 tons per day. Lee's staff had calculated that existing trucking operations could deliver perhaps 6,000 to 7,000 tons daily under optimal conditions. They needed to double that capacity, with the same number of trucks. Colonel Lauren Albert Ayres, nicknamed Little Patton for his aggressive leadership style, took charge of the operational planning. Ayres was a logistics officer who understood that moving supplies was fundamentally an industrial problem, not a military one. He approached it like an assembly line. He'd studied industrial efficiency methods before the war, Ford's assembly line, Taylor's time-motion studies, the emerging field of operations research. Now he would apply those principles to military logistics at a scale never before attempted. The problem could be broken down into component parts. Input: supplies arriving at Normandy ports. Throughput: truck capacity and route efficiency. Output: tonnage delivered to forward depots. Constraints: vehicle availability, driver capacity, fuel consumption, maintenance requirements, time. The goal: maximize output, given the constraints. Ayers gathered his planning team around a large table covered with maps, charts and calculations. "Gentlemen, we're going to redesign how this army moves supplies. We have 7,000 trucks. Each truck can carry 2.5 tons, theoretically. In practice, we're going to load them with 5 tons. That gives us 35,000 tons of cargo capacity in the entire fleet. The question is, how many round trips can we achieve per day?" A transportation officer raised his hand. "Sir, current operations average 1 round trip every 3 days. Ayers shook his head. "Unacceptable. We need 1 round trip per day, minimum. Some trucks will achieve 2 trips per day. Let's work backwards from that goal and identify every obstacle." They began listing bottlenecks. Loading time at origin. Currently 3-4 hours per truck. Transit time to destination, 8-9 hours at current speeds. Unloading time, 2-3 hours. Return transit, 8-9 hours. Fuel stops, 1 hour. Maintenance checks, 1 hour. Driver rest, 8 hours minimum. Total cycle time, 32 to 35 hours. That meant 1 round trip every 35 hours, or 0.7 trips per day. Ayers started crossing things out. Loading time. Why does it take 4 hours to load 1 truck? Because we're matching cargo to specific requisitions. Each item gets manifested, documented, assigned to a specific destination. What if we don't do any of that? What if we just fill the truck with whatever's available and send it? A quartermaster major objected. "Sir, then we won't know what's being delivered where. The depots won't be able to allocate supplies properly." "The depots will receive bulk tonnage," Ayers replied. "They'll sort it themselves. Our job is to move maximum tonnage, not to manage inventory. Loading time reduced to 30 minutes. He turned to transit time. 9 hours for 250 miles is too slow. That's under 30 miles per hour. The trucks can do better. We're going to create dedicated routes with no traffic, no stops, no intersections, no interference. Trucks will maintain 40 miles per hour sustained speed. Transit time reduced to 6 hours each way. Someone mentioned safety concerns. Ayers acknowledged them, but was unmoved. Every hour we save means more supplies reach the front. More supplies means the advance continues. The advance continuing means the war ends faster. We'll accept the risk." He moved to unloading. "Same principle as loading. Dump and go. No inventory control at the delivery point. Just get the cargo off the truck and get that truck back on the road. Unloading time reduced to 20 minutes. Driver rest was the most contentious issue. Army regulations required 8 hours rest in every 24-hour period. This was based on both performance and medical research. Sleep-deprived soldiers make mistakes. In combat, mistakes cost lives. Ayers understood this, but he also understood that sometimes you have to break the rules. 2-man crews. Each truck gets 2 drivers. They alternate. One drives while the other sleeps. When the active driver needs rest, they switch. The truck never stops except for fuel and loading. Actual rest time per driver, 4 hours per 12-hour shift. It's not optimal, but it's sustainable for the short term. A medical officer protested. "Sir, after a week of that schedule, cognitive function will be severely impaired. After 2 weeks, You're looking at serious health consequences. How long until the railroads are operational? Ayers asked. An engineer officer checked his notes. Optimistically, 6 weeks. Realistically, 8 to 10 weeks. Then we design this for 8 weeks of operations, Ayers said. After that, rail transport takes over and the trucks can stand down. 8 weeks of hard running. Can the men handle that? The medical officer hesitated. It'll be brutal. But yes, for 8 weeks, it's survivable. Ayers nodded and continued calculating. With the revised timeline, a full round trip would take loading 0.5 hours, transit outbound 6 hours, unloading 0.3 hours, transit return 6 hours fuel stops 0.5 hours, total 13.3 hours. That meant each truck could theoretically complete 1.8 round trips per day, with 6,000 operational trucks, allowing for 15% mechanical downtime, carrying 5 tons per load at 1.8 trips per day. That came to 54,000 tons per day, theoretical maximum. Ayers wrote the number on the board. The room went quiet. 54,000 tons per day was more than double what they needed. Of course, that was theoretical. Real-world operations never achieved theoretical maximum. Weather would cause delays. Accidents would tie up routes. Mechanical failures would reduce the operational fleet. Loading and unloading would take longer than planned. Drivers would be slower than calculated. Apply a reality correction factor of 40%, and the real-world expectation was about 21,600 tons per day, still above the 12,500 requirement. Ayers turned to his staff. This is achievable, but only if we commit completely. No half measures, no exceptions. Every truck operates on this schedule. Every driver follows these procedures. Every route is dedicated and protected. Can we do this? First, consolidate all available trucks into a single unified operation. The 132 separate transportation companies would be merged into one massive trucking system, all under single command, all following the same procedures, all operating on the same routes. Second, eliminate everything that slowed trucks down. The biggest time waster was traffic. Trucks competed with other military vehicles for road space. They got stuck behind slow-moving columns. They had to pull over for higher priority traffic. Solution: dedicated one-way routes. 2 parallel highways would be commandeered exclusively for supply trucks. One route northbound, carrying supplies to the front. One route southbound, carrying empty trucks back to Normandy. No other traffic allowed. No civilian vehicles. No military convoys, unless they were part of the supply operation. Nothing. The highways would be closed to everyone else. Third, maximize vehicle utilization. Every truck needed to make as many round trips as possible. That meant minimizing loading and unloading time. Standard procedure was to carefully load trucks with manifested cargo, each item recorded, each destination noted. This took hours. New procedure: dump and run. Trucks would be loaded with whatever was needed most. No manifests, no careful sorting. Just fill the truck and go. At the forward depots, trucks would dump their entire load and immediately head back for more. Sorting could happen later, at the depot. The truck's job was to move tonnage, not manage inventory. Fourth, double-team the drivers. Each truck would have 2 drivers. They would trade off every few hours. When one driver was exhausted, the other would take over. The truck would never stop except for fuel and maintenance. 24-hour operations. Fifth, create a priority system that actually meant something. The operation would be called Red Ball Express, adopting railroad terminology for express freight. Every truck in the system would have a red ball painted on it. Every cargo would be marked with a red ball. Every road sign would display a red ball. Everyone would know. If you see a red ball, it has absolute priority. Everything else gets out of the way. The planning was elegant in its simplicity. It was also completely unprecedented. Nobody had ever tried to operate a trucking system on this scale. The largest civilian trucking operations in America involved maybe a few hundred vehicles. This would be 6,000 trucks operating in perfect coordination across 500-mile routes. In a combat zone, with minimal maintenance facilities, on roads that were never designed for such traffic, using drivers who, in many cases, had never driven a truck before the war. The staff estimated they'd need approximately 23,000 personnel: drivers, mechanics, traffic controllers, loading supervisors, fuel handlers. Where would they come from? Every able-bodied soldier was needed for combat operations. The answer came from the segregated U.S. military. African American soldiers represented less than 10% of the army, but were overwhelmingly assigned to service units rather than combat roles. They served in the Quartermaster Corps, Transportation Corps, port battalions. They worked as mechanics, drivers, and stevedores, the humpers who loaded and unloaded supplies. They were skilled, disciplined, and available. Approximately 75% of Red Ball Express personnel would be black soldiers. Many of them had been asking for more responsible assignments, for a chance to contribute meaningfully to the war effort. Now, they would get that chance. The entire plan was sketched out, debated, revised, and finalized in 36 hours. On August 25, 1944, at 1,000 hours, the first Red Ball Express convoy rolled out of Cherbourg. 67 truck companies, 358 vehicles, carrying 4,482 tons of supplies. The experiment had begun. The engineering of logistics. The Red Ball Express route system was a masterpiece of practical engineering. 2 parallel roads were selected between Cherbourg and Chartres. The northern route, designated Red Ball Highway North, would carry loaded trucks eastward. The southern route, Red Ball Highway South, would carry empty trucks westward. The routes were carefully chosen, wide enough to handle military trucks, sturdy enough to bear the weight of continuous heavy traffic, with minimal towns or intersections that would require traffic control. Both routes were clearly marked. Red circular signs, 3 feet in diameter, were posted every kilometre. At intersections, larger directional signs guided drivers. Red Ball Highway, priority traffic only. French civilians were notified that these roads were now closed. Anyone attempting to use them would be turned back. Military police established checkpoints to enforce this. The system was ruthlessly efficient. At Cherbourg, the loading operation became an industrial process. Supplies came ashore via Liberty ships unloading at the damaged port facilities. Pallets of rations, crates of ammunition, jerry cans of fuel. Everything was staged in massive holding areas. Trucks arrived in waves, directed to specific loading zones. Quartermaster personnel, mostly African American soldiers, worked round-the-clock loading trucks. Speed mattered more than precision. A standard load for a 2.5-ton GMC Jimmy was actually closer to 5 tons. The trucks were overloaded by modern standards, but American engineering had built them tough. The Jimmy's suspension could handle it, the engine could pull it, and the brakes, well, drivers learned to be careful. Loading time was reduced to 30 minutes per truck, sometimes less. As soon as a truck was loaded, it joined the convoy queue. Once 5 or more trucks were ready, they formed a convoy and headed out. In theory, convoys were supposed to be escorted by jeeps in front and rear. In practice, individual trucks often departed as soon as they were loaded. The urgency was too great to wait for proper convoy assembly. On the road, the system functioned like a conveyor belt. Trucks rolled eastward in an endless stream. The official speed limit was 25 miles per hour. This was for safety. The roads were narrow, the trucks were overloaded, and visibility was often poor. Many drivers ignored this regulation. Engine governors that limited speed were frequently adjusted. Trucks routinely reached 45–50 miles per hour on straight sections. The result was accidents and breakdowns and chaos, but also speed. Every hour saved meant more tonnage delivered. Traffic control was maintained by military police stationed at intervals along the route. Their job was to keep traffic moving. Broken down trucks were pushed to the side of the road immediately. No stopping to fix minor problems. If it could still roll, it kept rolling. Major repairs happened at designated maintenance points, but trucks with minor issues were expected to complete their run. The drivers developed a saying, "If it's rolling, it's rolling." Fuel stops were pre-positioned every 100 miles. Trucks pulled in, refueled in 10 minutes or less, and got back on the road. The fuel stops also served food. Drivers grabbed sandwiches and coffee without leaving their vehicles. The goal was never to stop moving. At night, the operation continued. Drivers operated with cat-eye blackout lights, tiny slits that showed just enough illumination to follow the truck ahead. This was to avoid attracting German bombers. In practice, the Luftwaffe rarely appeared. German air power was effectively destroyed by this point in the war, but the blackout driving created its own hazards. Drivers had to follow the truck ahead by watching its tail lights. If they lost sight of those lights, they were driving blind. Accidents spiked at night, but stopping wasn't an option. The schedule demanded 24-hour operations. At Chartres, the unloading process was equally streamlined. Forward depots, massive open-air staging areas, received the trucks. Drivers simply dumped their cargo into designated zones. Ammunition here, rations there, fuel over there. No manifests to sign. No inventory to reconcile. Just unload and go. Sorting would happen later. The priority was getting the empty truck back to Normandy for another load. Turnaround time at forward depots, 20 minutes. The southbound return route operated the same way. Continuous flow, minimal stops, absolute priority. Empty trucks raced back to Cherbourg to start the cycle again. The entire system was designed around one principle: maximize tonnage per hour. Everything else was secondary. Safety was secondary. Inventory control was secondary. Proper maintenance procedures were secondary. Driver rest was secondary. The only thing that mattered was keeping supplies moving. It was brutal, dangerous, exhausting work. It was also extraordinarily effective. The reality of 24-hour operations. The first week of Red Ball operations revealed problems the 36-hour planning session couldn't have anticipated. Problem 1, night driving. The blackout regulations required all vehicles to operate with minimal lighting. Cat-eye covers reduced headlights to tiny slits, barely brighter than a candle. This was necessary to avoid attracting German bombers, but it made driving nearly impossible. Drivers could see perhaps 20 feet ahead, maybe 30 feet on a moonlit night. At 40 miles per hour, that gave them less than half a second of reaction time. If the truck ahead braked suddenly, you crashed into it before you realized what was happening. If there was an obstacle in the road, a pothole, debris, a broken-down vehicle, you hit it before you saw it. If the road curved unexpectedly, you drove straight off into a ditch. Night accidents spiked immediately. Within the first 3 days, 47 trucks were damaged or destroyed in nighttime collisions. 3 drivers were killed. 12 more were injured seriously enough to require hospitalization. The solution came from the drivers themselves. Sergeant William Davis of the 513th Quartermaster Truck Company developed a technique. Rather than trying to see the road, follow the truck ahead. Watch its tail lights. Keep a fixed distance, about 3 truck lengths. When the tail lights ahead move, you move. When they stop, you stop. When they turn, you turn. Don't look at the road. Look at the tail lights. The technique spread through the convoy network within days. It worked. Accident rates dropped by 60%. But it created a different problem: dependency chains. If the lead truck made a mistake, every truck behind it made the same mistake. Lead driver missed a turn. 20 trucks behind him missed the turn. Lead driver went too fast into a curve. 20 trucks behind him went too fast. The system was only as good as the lead driver, which meant lead drivers had to be the best, most experienced, most alert drivers available. They also had to stay awake no matter what. If a lead driver fell asleep, the entire convoy behind him would follow him straight off the road. Problem 2, maintenance. The GMC Jimmy was a robust truck, but no vehicle could handle continuous operation at overload capacity without breaking down. The most common failures were predictable. Tire blowouts. The overloaded trucks stressed the rubber beyond its design limits. Average tire life, 3,000 miles under normal conditions. Red Ball tire life, 800–1,200 miles. With trucks covering 500 miles per round trip, tires were failing constantly. Brake fade. Continuous high-speed driving with heavy loads generated tremendous heat. Brake drums would overheat, causing the brakes to lose effectiveness. Drivers learned to anticipate this. Going downhill, they'd downshift to use engine braking rather than relying solely on the brakes, but that meant grinding the transmission, which created its own problems. Overheating. The engines ran hard continuously. Cooling systems struggled to keep up. Radiators boiled over. Water pumps failed. Thermostats stuck. The solution was to add additional cooling stops. Every 100 miles, trucks would pull over for 10 minutes to let engines cool. This added time to the schedule, but prevented catastrophic engine failures. Electrical problems. The constant vibration loosened connections. Wiring harnesses chafed and shorted out. Generators failed. Batteries died. These were harder to fix in the field. A tire could be changed in 15 minutes. An electrical problem might take hours to diagnose and repair. Maintenance units were established every 50 miles along both routes. Each unit had a small team of mechanics, a supply of common spare parts, and tools. When a truck broke down, the driver would try to limp to the nearest maintenance unit. If that wasn't possible, a repair team would come to the truck. The mechanics were miracle workers. They kept trucks running with minimal parts, improvised repairs, and sheer determination. But they were overwhelmed. By week 2, approximately 25% of the Red Ball fleet was deadlined, broken down and awaiting repair. That meant the operational trucks had to work even harder, which caused more breakdowns. It was a vicious cycle. Problem 3. Fuel consumption. The planning had assumed 6 miles per gallon fuel efficiency. Reality was closer to 4 mpg with the overloaded trucks. That meant each truck consumed approximately 125 gallons of fuel per round trip. With 5,000 trucks operating, that was 625,000 gallons of fuel per day just to run the Red Ball itself, nearly as much as an entire armoured division consumed. The Red Ball was eating its own supplies. Fuel logistics became a critical sub-operation. Tanker trucks had to be diverted from delivering fuel to combat units to instead supply Red Ball refueling points. This reduced the amount of combat fuel reaching the front, which somewhat defeated the purpose of the Red Ball. The solution was to establish a parallel fuel pipeline. Engineers laid temporary pipelines from Normandy ports to refueling points along the Red Ball routes. These pipelines, built from sections that could be rapidly connected, delivered fuel more efficiently than tanker trucks. By mid-September, the pipeline system was operational. it delivered 800,000 gallons per day directly to Red Ball refueling stations. This freed up tanker trucks to deliver fuel to combat units. Problem 4. Coordination between loading and unloading. The Red Ball was designed for speed. Load quickly, drive fast, unload quickly, return. But quickly is relative. If trucks arrived at Chartres faster than the depot could unload them, trucks would stack up waiting. Waiting trucks weren't delivering tonnage. If trucks arrived at Cherbourg faster than loaders could prepare cargo, trucks would sit idle. Idle trucks weren't delivering tonnage. The system needed perfect balance. This required real-time communication and adaptive scheduling. The Signal Corps installed teletype machines at major control points. Every hour, each depot would report: trucks unloaded in the past hour, trucks currently being unloaded, trucks waiting to unload, available unloading capacity. This information went to the Central Coordination Office. Coordinators would then signal loading points, increase, decrease loading rate, prioritize specific commodities, hold trucks if depots were backed up, expedite trucks if depots had excess capacity. The system worked but required constant attention. Coordinators worked 12-hour shifts, monitoring teletype reports, calculating throughput rates, issuing orders. It was mentally exhausting work, but it kept the system balanced. Problem 5. Weather. August 1944 in northern France was generally good weather. Warm, dry, clear, perfect for truck operations. September brought rain. A lot of rain. The French roads, already stressed by continuous heavy traffic, began to deteriorate. Pavement cracked, gravel surfaces washed out. Dirt roads became mud pits. Trucks got stuck. Traffic backed up. Schedules slipped. The Engineer Corps deployed road maintenance teams. They worked alongside the convoys, filling potholes, reinforcing soft spots, laying temporary surface material. It was like trying to maintain a highway while thousands of trucks drove over it continuously. But it kept the roads barely functional. The September rains also revealed another problem: visibility. Rain on windshields, combined with blackout driving restrictions, made night operations nearly impossible. Accident rates spiked again. The only solution was to slow down. Speed limits were reduced to 20 mph during heavy rain at night. This cut delivery capacity by 40%. But it was better than having trucks crashing constantly. Problem 6. German interference. The Luftwaffe was largely defeated by August 1944. German air power couldn't seriously threaten the Red Ball, but German ground forces still held pockets behind Allied lines. Bypass operations had left small German units scattered across France. Most were trying to escape eastward or surrender. Some decided to cause trouble first. The Red Ball routes passed through areas where German stragglers might be present. Incidents occurred. Snipers took shots at truck convoys. Landmines were placed on roads. A few trucks were ambushed. The casualties were light, maybe 30 to 40 Red Ball personnel killed or wounded by German action over the entire operation. But it created psychological stress. Drivers knew they might be targeted. Every shadow could be a sniper. Every bump in the road could be a mine. This added to the existing stress of fatigue, mechanical problems, and dangerous driving conditions. The solution was armed escorts. Jeeps with mounted machine guns accompanied convoys through suspected danger areas. Infantry patrols swept the routes regularly. French resistance fighters provided intelligence on German movements. The threat never completely disappeared, but it was managed. Problem 7. Inventory chaos at depots. The dump-and-run loading system created massive disorganization at forward depots. Trucks would arrive and dump 5 tons of mixed supplies. artillery shells mixed with rations, mixed with medical supplies, mixed with spare parts. Depot personnel had to sort through mountains of unsorted cargo, find what combat units needed, separate by type, organize for distribution. It was a nightmare. By late August, the forward depots at Chartres had over 50,000 tons of supplies, and nobody knew exactly what they had. Combat units would requisition specific items. Depot personnel would spend hours searching for them, sometimes finding them, sometimes not, sometimes finding them months later after they were no longer needed. The solution was imperfect. Accept the chaos. The Red Ball's job was to move tonnage. Organizing that tonnage was someone else's problem. Eventually, additional quartermaster units were assigned to depot operations, specifically to sort and organize the incoming chaos. It wasn't elegant, but it worked. The supplies reached the depots. Eventually, they reached the units that needed them. Eventually was better than never. The human cost. Private First Class Emmett Jenkins had been driving for 19 hours straight. His assistant driver, Corporal David Washington, was asleep in the passenger seat. Jenkins had been supposed to wake him 3 hours ago to trade off, but Washington had looked so exhausted that Jenkins had let him sleep. Now Jenkins was paying the price. His eyes burned. His hands ached from gripping the steering wheel. His back felt like it was fused to the seat. The road ahead blurred and doubled. Jenkins shook his head violently, trying to force himself awake. He reached for the canteen of coffee that had gone cold hours ago and drained it anyway. Somewhere up ahead was Chartres. Maybe 20 more miles. He could make it 20 miles. He had to make it 20 miles. Behind him, 32,000 pounds of ammunition depended on it. This was the reality of the Red Ball Express. The statistics were impressive. 12,500 tons per day. 5,958 vehicles for 12,000 total tons delivered over 83 days. But statistics didn't capture what it felt like, driving 18, 20, sometimes 24 hours with minimal rest, operating overloaded trucks at dangerous speeds on unfamiliar roads, maintaining constant vigilance for breakdowns, accidents, and the ever-present possibility of German stragglers or saboteurs, doing it day after day, week after week, with no end in sight. The drivers called it the endless road. Sleep deprivation was the universal enemy. The human body isn't designed to function on 3 to 4 hours of sleep per day. After a week, cognitive function deteriorates significantly. After 2 weeks, drivers were operating in a fog of exhaustion. Many developed tricks to stay awake, singing at the top of their lungs, slapping themselves in the face, sticking their heads out the window to get blasted by cold air. One driver kept a wet towel and would periodically wipe his face down. Another kept ammonia capsules that he'd crack open and sniff when drowsiness hit. The most common method was simply talking to their assistant driver. Conversation required active brain engagement. As long as you were talking, you weren't falling asleep. But when the assistant driver was asleep, or when you were alone in the cab at 3 a.m. with nothing but darkness and the hypnotic rhythm of the engine, that's when drivers nodded off. The first sign was usually drifting out of the convoy. A truck would start to wander, weaving across the road. Other drivers would honk their horns, flash their lights. Sometimes it worked. The drowsy driver would snap awake, jerk the wheel, and get back in line. Sometimes it didn't work. Sometimes the truck kept drifting until it hit something. Another truck, a tree, a roadside ditch. Private Robert Emmerich of the 3580th Quartermaster Truck Company remembered waking up to the sound of blaring horns and screaming brakes. He'd been driving through the night, and at some point he'd simply passed out. His truck had drifted into oncoming traffic on the southbound route. Only the quick reactions of other drivers had prevented a catastrophic pile-up. Emmerich pulled over, shaking. His assistant driver took over. They completed the run. But Emmerich still had nightmares about it years later. Mechanical failures were constant. The GMC Jimmy was a robust vehicle, but it wasn't designed for continuous operation at overload capacity. Transmissions failed. Brakes wore out. Engines overheated. Tires blew out constantly. Maintenance procedures called for regular inspections and preventive maintenance. The Red Ball Express didn't have time for that. Trucks ran until they broke. Then they were fixed if possible, or abandoned if not. Mechanics worked miracles keeping the fleet operational. Many of them were African American soldiers who'd been mechanics in civilian life. They knew trucks. They knew how to jury-rig repairs with whatever materials were available. They kept the Red Ball rolling. But there were limits to what even skilled mechanics could achieve. By September, the mechanical readiness rate had dropped to about 70%. That meant 30% of trucks were out of service at any given time. The operational trucks had to work even harder to compensate, which caused more breakdowns, which reduced the operational fleet further. It was an unsustainable cycle. The psychological toll was perhaps the hardest to quantify. African American soldiers faced unique challenges. They were doing essential, dangerous work. They knew their contribution was critical to the Allied advance. But they also knew that when the war ended, they'd return to a segregated society that wouldn't recognize their service. They couldn't eat at many restaurants in their own country. They couldn't vote in many states. They faced discrimination, violence, and systemic inequality. Yet here they were, risking their lives to supply an army fighting for freedom in Europe. The irony wasn't lost on them. Many Red Ball veterans spoke about this years later. They were proud of their service, proud of what they'd accomplished, but also frustrated, angry, and disillusioned by the contrast between the ideals they were fighting for and the reality they lived with. Despite all of this, the exhaustion, the danger, the mechanical failures, the discrimination, the Red Ball Express kept rolling, because the alternative was unacceptable. If the trucks stopped, the armies stopped. If the armies stopped, the Germans escaped. If the Germans escaped, the war continued. So, the trucks kept rolling. The mathematics of war. By September 5, 1944, the Red Ball Express had been operating for 11 days. The results were measurable and dramatic. Total tonnage delivered 89,139 tons. Average daily delivery 8,176 tons. Peak daily delivery, August 29th, 12,942 tons. The logistics crisis had been averted. Patton's Third Army resumed its advance. First Army pushed toward the Siegfried Line. The German retreat continued. But the numbers told a more complex story. Let's examine what 89,939 tons actually represented in operational terms. Fuel accounted for approximately 40% of total tonnage. That's 35,976 tons of gasoline, diesel fuel, and lubricants. At 6.7 pounds per gallon, that equals 10.7 million gallons of fuel, enough to move an entire armoured division for 71 days, or to keep Patton's entire Third Army mobile for 13 days. Those 13 days were the difference between pursuing a defeated enemy and watching him escape. Ammunition represented roughly 35% of tonnage, 31,479 tons. To put this in perspective, consider the variety. 150 Farmfennen artillery shells, the workhorses of American artillery. Weight per shell, 95 pounds. 31,479 tons could be approximately 662,000 shells. That's enough ammunition for a corps-level artillery bombardment lasting 23 days of sustained fire, or for 46 days of normal combat operations, or for a single day of absolutely apocalyptic fire support if concentrated. But ammunition wasn't just artillery shells. Tank main gun rounds, 75 mm kittens for Shermans, 76 mittens for upgunned variants, 90 mm for tank destroyers, mortar rounds, 60 meters Mitten and 4.2-inch chemical mortars, small arms ammunition, millions of rounds of 30 caliber for rifles and machine guns, 45 caliber for pistols and submachine guns, 50 caliber for heavy machine guns, hand grenades, rifle grenades, mines, explosives. Each type had to be delivered in the right proportions to the right units. The Red Ball didn't manage that proportioning. It just moved tonnage. But the tonnage it moved included all of these categories. Rations comprised about 15% of tonnage, 13,491 tons. American soldiers consumed approximately 6 pounds of food per day. 13,491 tons equals 4.5 million man-days of rations. That would feed one soldier for 12,300 years, or feed 28 divisions, for 20,000 men, for 11 days. The Red Ball kept the army fed during the critical pursuit phase. Soldiers who aren't starving fight better than soldiers who are. Simple, but true. The remaining 10%, 8,194 tons, covered everything else. Medical supplies, plasma, morphine, sulfur drugs, bandages, surgical equipment, spare parts, tank tracks, engine components, radio tubes, tyre patches, signal equipment, telephone wire, field phones, radio batteries, engineer supplies, explosives, bridging equipment, wire cutters, quartermaster items, uniforms, boots, blankets, tentage, all the thousands of items that a modern army needs to function. 8,176 tons per day average was impressive. It was also insufficient. The original requirement was 12,500 tons per day. The peak performance of 12,342 tons had been achieved exactly once, in the first week of operations when everything was new, trucks were freshly maintained, and drivers were still relatively rested. That performance level lasted exactly 4 days. August 26-29 saw deliveries of 11,840, 12,193, 12,342, and 11,678 tons, respectively. Then reality set in. August 30th, 10,456 tons. August 31st, 9,878 tons. September 1st, 9,123 tons. The decline continued throughout September and into October. This wasn't failure, it was mathematics. Every system has a theoretical maximum and a sustainable operating level. The difference between them is called performance decay by engineers. For the Red Ball, performance decay was driven by multiple factors. Mechanical wear. Trucks broke down more frequently as mileage accumulated. Driver fatigue. Exhausted drivers made mistakes, drove slower, needed more rest. Route degradation. Roads wore out under constant heavy traffic. Weather impacts. September rains slowed everything down. Administrative friction. Coordination problems accumulated over time. Distance increases. As the front advanced, round-trip distances grew longer. All of these factors compounded. The result was inevitable decline from peak performance. By late September, daily tonnage had dropped to 5,088 tons, still significant, still valuable. But less than half the peak rate. The system was grinding itself down. By October, it was down to 2,711 tons. The system was grinding itself down. Truck breakdowns were accelerating. Driver fatigue was becoming critical, and the distance was increasing. The front lines kept moving eastward. Chartres was no longer the forward depot. New depots were established farther east: Reims, Verdun, Metz. Round-trip distances increased from 500 miles to 600, then 700, then 800 miles. Longer distances meant fewer trips per day. Fewer trips meant less tonnage delivered. The Red Ball was a victim of its own success. It had enabled the Allied advance. That advance had outrun the Red Ball's capacity. The solution came from an unexpected source: logistics infrastructure. Engineers had been working frantically to restore the French rail system. By early October, key rail lines were operational. A train could carry 1,500 tons of cargo in one trip. That was equivalent to 600 truckloads. A train didn't need to stop for driver rest. It didn't have mechanical failures every few hundred miles. It didn't require 23,000 personnel to operate. Rail was simply more efficient than trucks for long-distance bulk transport. The Army had always known this. The Red Ball Express had never been intended as a permanent solution. It was a stopgap measure, a way to keep supplies flowing until proper infrastructure could be established. By November, that infrastructure was in place. Rail lines from Normandy to forward depots were operational. The port of Antwerp had been captured and cleared of German mines. Portable fuel pipelines had been laid across France. The logistics system had matured. On November 16, 1944, the Red Ball Express officially ceased operations. The last convoy delivered its cargo and disbanded. The trucks were redistributed to their original transportation companies. The drivers returned to regular assignments. The system that had moved an army across a continent in 83 days was no more. But its legacy remained. Resolution: lessons from the Red Ball. The Red Ball Express delivered 401,000 tons of supplies over 83 days of operation. That's an average of 4,964 tons per day. To put that in perspective, consider what that tonnage represented. 12,000 tons is equivalent to 103 million gallons of gasoline, 8.8 million artillery shells, 206 million rations, or enough supplies to support approximately 28 divisions for 83 days. The Red Ball kept the Allied advance moving during the critical months when German forces were most vulnerable. Without it, the pursuit across France would have stalled. German forces would have established defensive positions. The war might have dragged on for additional months, possibly years. The human cost of such a delay is incalculable. In that sense, the Red Ball Express helped save lives by helping end the war faster. But the immediate statistics don't tell the full story. The Red Ball's real contribution was proving that logistics could be improvised at scale. Before the Red Ball, conventional wisdom said you needed established infrastructure, ports, rail lines, supply depots, before mounting large-scale operations. The Red Ball demonstrated that you could operate without that infrastructure, at least temporarily, if you were willing to accept the costs. Those costs were substantial: mechanical attrition rates of 30%, accident rates far higher than normal operations, driver fatigue that bordered on dangerous, maintenance standards that sacrificed long-term reliability for short-term performance, an inventory control system that was essentially organized chaos. None of this would be acceptable in peacetime. But in war, acceptable means whatever keeps you winning. The Red Ball kept the Allies winning. The operation also highlighted the critical importance of African American soldiers to the American war effort. 75% of Red Ball personnel were black soldiers who performed with extraordinary skill and dedication. They proved that given the opportunity and the responsibility, they were equal to any challenge. This didn't immediately change the segregated military. That wouldn't happen until President Truman's executive order in 1948. But it planted seeds. Officers who served with Red Ball units saw firsthand the capabilities of African American soldiers. They carried those observations forward. The Red Ball became a case study in military logistics education. It appeared in Army Staff College curricula. It influenced the development of logistics doctrine in the Korean War. Elements of the Red Ball concept, dedicated supply routes, priority traffic systems, maximized vehicle utilization, became standard practice. The term Red Ball itself lived on. During the Korean War in 1950, a Red Ball Express supply system operated around the Pusan perimeter. In Vietnam in 1966, Another Red Ball system moved supplies along Route 19. The name became synonymous with emergency logistics operations, where speed mattered more than perfection. The vehicles themselves became legendary. The GMC CCKW 2.5-ton truck, the Jimmy, became one of the iconic vehicles of World War II. Over 560,000 were produced during the war. They served in every theatre. They became the backbone of American military logistics, and a significant number of them earned their reputation on the Red Ball Express. After the war, military historians studied the operation extensively. The conclusion was consistent. The Red Ball Express was a success, but barely. It operated at the absolute limit of what was logistically possible. Any additional stress, worse weather, more aggressive German interdiction, longer distances, would have caused complete failure. The margin between success and disaster had been razor thin. This led to important lessons. First, logistics must be planned for the best-case scenario, not the expected scenario. If you plan for a methodical advance and get a rapid pursuit, you're in trouble. Better to have excess capacity that goes unused than insufficient capacity that causes failure. Second, infrastructure matters more than improvisation. The Red Ball worked, but rail transport was always more efficient. Building proper logistics infrastructure should be a priority, not an afterthought. Third, soldier welfare matters. The Red Ball got away with grinding its personnel down because the operation lasted only 83 days. If it had continued for 6 months, the human cost would have been catastrophic. Sustainable operations require sustainable personnel policies. Fourth, diversity is strength. The African American soldiers of the Red Ball Express performed superbly. Excluding capable personnel from critical roles for reasons of prejudice weakens the entire organization. Modern military logistics owes a debt to the Red Ball Express. Modern supply chains, civilian and military, use many of the concepts the Red Ball pioneered: dedicated routes, priority systems, just-in-time delivery, maximized asset utilization. The terminology may have changed, but the principles remain. In the end, the Red Ball Express was exactly what it needed to be: not perfect, not sustainable, not pretty, but effective. It moved an army across a continent when that army needed to move. It kept supplies flowing when failure would have meant disaster. It proved that logistics problems could be solved with determination, ingenuity, and exhausting amounts of hard work. The Red Ball Express lasted 83 days. Its legacy has lasted 80 years, and counting.